Hello, guys. So today let's try another coding question for Facebook. This is the third most popular ones for the past year for Facebook. So let's try. Okay. So for this question, we're gonna do the minimum remove to make valid parentheses. So we have a string of parentheses and then lowercase English letters, and we're gonna remove the invalid parentheses to make it a valid string. All right, I see. So, so for example, like for this input, we have like this can be a valid pair, and the second one can be a valid pair, and then this is the extra one, which can be invalid parentheses. So we can return this, or we can make it like this one maps to this, and this one maps to this, and this is the extra one. So yeah, so this is will be a valid solution, and then like there are other valid solutions. So we, as long as we make it like with valid parentheses pairs, then it will be a valid return string. So in this case, we have an extra right parenthesis here, so we just remove it and we return this. So for most of the case, like 90% of the case, when we deal with parentheses in the coding question, we're gonna use a stack. So we're gonna use a stack to map the pairs of parentheses. So in this case, what we can do is we can have a stack, and then every time we see a left one, we just append it to a stack. So like in this case, we just append the position of 0, 1, 2, 3, the position of 3 into a stack. And then we see another one at 5, then we just append it to 5. So we are seeing like, which means we have two left parentheses in our string right now. And then we see a right one. As long as we see a right one, which means we can, the parentheses at the position 5 will be mapped to this right one, so that they can become a pair of parentheses. So we can just pop it out from the stack, and then we see another one, so we can pop this out into the stack, and then we see another one. However, we don't have any left parentheses in our stack right now, so this must be an invalid right parenthesis. So we can mark this as invalid, and then we need to remove that from the string. And another case is this one. Let me just move them down a bit. So in this case, we see a right parenthesis, and our stack is empty, which means like this is an extra right parenthesis, which doesn't have a left one to pair it with. So this must be invalid. And then we see a right one, we just push it to stack. And then we see a left one, we pop the one from the stack, and then these two can form a pair. And then like we reach the end of the string, so we return this as a output. So basically, we're just gonna use a stack and then maintain the unused right parentheses in the stack, and then pop them out if we see a left one. So yeah, so let's try to code it out. All right, and this will return the string. So I see. So let's try to get a stack first. Stack. So the stack will maintain the sorry, maintain the left ones, unused left ones. And then we also need to keep a record of invalid positions. So as long as we see an invalid position, we just push it into that, and then we can just remove them or in the end to return the output string. All right, so for I and the char in enumerate over the string. If char equal to, if char is, sorry, I'm confused with the syntax. If char equals to the left one, then we just push it to stack, so that stack dot add under the index. So this is the index of the left parentheses, the unused ones. If char equal to the left one, all right, then what we're gonna do is, like, in this case, if there's no stack, if the stack is empty, if not stack, if the stack is empty, then we know it's an invalid position. This is invalid left parenthesis, invalid position dot and I. Otherwise, we just pop it up, stack dot pop. So we just extract the last left parenthesis from the stack so that it can pair with the current right parenthesis. All right. And in the end, if there's an extra, if stack, so if there's an extra left parenthesis in the stack, like we left over, the unused ones, then all these are invalid. Then we can just extend, I think. Yeah, extend. We just extend, append all of them into the invalid positions. So these are all the invalid positions for the parentheses. All right, so now we're gonna remove all the invalid positions out. So for string manipulation, if we like manipulate string, it'll be order of n, because we have to rewrite every character into the string. So in order to make it more time complexity wise more efficient, we can like split string into an list, and then we can modify every item in the list that will be order of one time complexity. So it will be more efficient time wise. So we can just like manipulate the string into a list. So we convert the string into a list. Okay, so now for every position in invalid positions, we just rewrite the position to be an empty string. So just make it empty. And then we can join it again. Response will be like we can join the list. All right, so this will be order of n complexity. All right, let's see how it goes. Yeah, and it's all correct. So for time complexity wise, as I already mentioned, it will be order of n for looping through the string, and the order of n to remove the positions, because we convert the string to a list and then manipulate from there. So it will be order of n. And for space complexity wise, like we maintain the stack and the invalid positions, which will be maximum order of n when we have everything invalid, or like if the entire string, the string contains like right position, all of the items in the string is like a right parenthesis, then space complexity will be order of n. So that's the worst space complexity. All right, that's it, and see you guys later.